Okay, factorising quadratics are completing the square. Sometimes I'll call this forcing the square, and I'll detail why later, but completing the square is the general phrase for it. Cool, alright, so what we're going to do, we're going to do this the previous way that we had before. So we go down our checklist. Number one, factor anything that's common. Okay, is there anything in common? No, can't do that in this case. Okay, what's after that? Recognition. So are there two things that times the end and add to the middle? Well, yeah, there are. There's 3 and 3 again. So I could write this as this, but as always, mathematician, we're trying to be super efficient. I'm just saying the same thing twice. Something times itself. That's just this. Okay, great. Well, where can I go from there? Well, no, that's done. That's factorized. Great. Don't care so much about that. What about this thing? Alright, well, we'll go through the list again. Okay, anything in common? No. Okay. Recognition. Is there anything that can times the end and add to the middle? Well, I've got 7 and 1 on that end. 7 and 1 gives me 8. Well, that's no good. Oh, maybe I could do negatives. Negative 1 and negative 7, that gives me negative 8. Oh, doesn't look like I can do that. Alright. Well, what else have we got? After recognition, well, that's no good. I've got grouping, but I need 4 things for that. Difference of 2 squares, that's no good. I need 2 things for that. Looks like we're a bit stuck. Looks like we're going to need completing the square. So, what I would have you notice is that this and this are a little bit close. So, this and this have to be the same thing, just 2 minus off from this. So this thing must be the same as that. And you can check, you can throw in a whole bunch of numbers for x and it turns out, yeah, that is exactly the same. Okay, well, how can we more systematically do this without having to happen to have this thing sitting on the left? Well, the reason this is called completing the square is because what we've done is gone, oh, how much more do I need to make this a perfect square? Well, if I said add 2 to this, alright, then this turns into a 9, and then I can potentially recognize that this is a perfect square factor. Well, that's a little bit fiddly, so I'm going to teach you a slightly better way of thinking about it, because it just generalizes a bit better. Here's what we're going to do. We're going to take this number and halve it. So we already know what the answer is going to be. Actually, we'll just get rid of it. We already know what the answer will be. It'll be this thing minus 2. But let's say that we didn't have this for reference. We're going to take the middle thing and halve it. Okay, so I get that. Cool, we're already almost there. Then at the end, I'm going to write plus k. Now, why have I picked k? K for some number. Right, you can pick whatever letter you want, you can draw a smiley face, whatever, doesn't matter, it's just a placeholder. Great, from there, I want these 2 things to be the same. Okay, well if they're the same, when I expand them, they should also be the same. So if I expand this out, keeping in mind that this is a factor times a factor, so I've got x by x, and then I'll have x by 3 in the next one, so 3x plus another x by 3, and then 3 by 3 gives me 9. And then I still have that. Okay, great. Can I neaten this? Yeah, definitely can. I get x squared plus 6x plus 9 plus k. Okay, great. Well, these and these are really similar. That's the same, that's the same. This is the only part that's not the same. Okay, what does that k have to be in order to make these the same? So I can, on the side, I can go, alright, 7 has to equal 9 plus k. Alright, I could minus 9 off both sides, gives me negative 2 is k. Be conscious about doing this in your head because it's very easy to get your plus minuses mixed up. Cool, so this must be the same as x squared plus 6x plus 9, and then green, minus 2. Well, that's fine because I know this blue is the same as that blue, so this k has become negative 2. Minus 2. And lo and behold, that's what we had before. Brilliant. So we've got a new way of factorising things that otherwise we couldn't touch before. Okay, great. Now, as you get faster at this, you'll be able to just write from here, write that, think about it, and then write that. You'll be able to jump a lot of these steps for nice numbers. Sometimes you'll need some intermediate steps, particularly when ugly numbers turn up. But for now, I'm quite happy for you to just very, very slowly plod your way through and just keep things careful. Okay, well, let's try something new that we haven't seen the other version of yet. Okay, first step. We're going to halve that and put it in a factor. So x plus 4 squared, and plus some unknown k. Okay, great. Well, what happens if I expand this out? I'd get x squared plus 8x plus 16. If you're not sure where that 8x came from, just write out x plus 4, expand it out and simplify, you'll end up back there. Cool, plus some k. Okay, great. Well, hang on, I need this to equal that, because this matches, I need those two to match. So 2 has to equal 16 plus k, minus 16 off both sides, k is negative 14. So I get my blue bit minus 14. Excellent. Cool. Okay, well, let's go next thing. Alright, well, halving this guy. So we've got x minus 5. Okay, plus some unknown k. Beautiful. Okay, if I expand this out, as always, I'm going to start to teach you some shortness here. Okay, if I expand this out, I already know that I should get x squared and then minus 10x, so I'm not even going to bother to write that now. I'm just going to write what this thing squares to. Negative 5 by negative 5 is 25. And I'll have this plus k on the end. Brilliant. What I need that to equal, though, is this guy, so that should equal 4. Okay, minus 25 from that, so I get minus 21. Beautiful. So we get x minus 5 squared, k is negative 21. Done. Fantastic. Alright, well, let's go over to the slightly more annoying stuff. Alright, exact same logic. Okay, halve that thing. Alright then, I get x minus, oh, that doesn't halve nicely. Well, it's just a fraction. Don't be afraid of fractions, they're numbers too. Cool, plus some unknown k. And this is where it saves us a bit of time. We're not going to bother to write out these first two again. We're just going to say, excuse me, square this. Well, that gives me 3 squared 9 over 2 squared 4. Plus unknown k has to equal 4. Is that the colouring scheme? Yep, that's the colouring scheme I got. Great. Okay. Well, solving this for k, well, that's a little bit fiddly, but you can just write 9 on 4 plus k on, on plus k rather, has to equal, I need this on 4, so that's 16. 16 on 4 is 4. Great. Well, 9 plus something is 16, okay, k is therefore 7 on 4. So we get minus 3 on 2 squared, that's positive now, positive 7 on 4. Brilliant. So we got that result. Okay, fine. Well, what about this guy? Oh, that's annoying again because we're halving this middle thing. That's not as nice a number as we'd like, but we can still do it. Even if that was a fraction, you can halve fractions too. Okie dokie. Cool, we don't have to bother with the whole front bit, we can just expand from here. So 5 squared, 25, 2 squared, 4, plus our unknown k is going to equal what we actually need, 6. Now, I could write 6, or I could just immediately go, hang on, I'm going to need this over 4. So I'll change it to 24 on 4. Cool, great, 25 plus something gives me 24, so k must be negative 1 on 4. Cool, so I've got x minus 5 on 2 squared minus 1 over 4. Beautiful. Okay. That's all well and good, so we've done completing the square on those. Now I'm taking a look at this guy and go, oh okay, should I just halve this and go nuts? Well no, this only worked for when this was a monic, so when you've got just a single x squared. So are we stuffed? Well, actually no, because, as always, if you run down your list, common happens first, okay? We can take a 4 out the very front. So we get this. Beautiful. Cool, okay, well, now I'm going to consider this bit. Okay, so that guy gets halved. Okay, x squared plus, oops, just x rather, plus 2 all squared plus some unknown k. Okay, well I've got to be a little bit careful here because I've got this extra set of brackets around what I'm looking at. So I'll put those brackets there and keep the 4 out the front. Cool, okay. If I was to expand this out, I'd have 2 squared is 4 plus the k, plus the k has to equal, keeping in mind we're still in the orange bracket, has to equal that 1. Okay. Yep. Cool. Well, k would have to be -3. So we've got 4, orange bracket, blue, x plus 2 squared minus 3. Brilliant. Now, are these orange brackets necessary? Well, what we could do is just multiply that 4 into everything by writing that. So I've done the 4 times this, which just sits out front. 4 times -3 gives you -12. Now you can always check these by either expanding it, or you can throw in a couple numbers just to make sure they're equal. Okay, that's fine. Cool, if we take a look at this guy, well, this looks like it'll be alright. So we'll halve that middle number, so I get x minus 1 squared plus some k. Okay, 1 squared, sorry, -1 all squared is still +1 plus some k. Equals, what colour to do that in? Purple. Equals 4, that's fine. So k is +3. Beautiful. Yep. X minus 1 squared. Did I do this in green usually? Yep, +3. Okay, fine. So that one was super simple. So why did I leave that at the end? Well, there's one more thing that I want to show you. If we go back to these, is there another way of writing this? Well, I've got something squared minus something else. So hopefully me saying squared out loud should probably trigger in your mind, we could run difference of 2 squares on this thing. So we go, oh, this whole thing is the first squared number, so we get the first number plus the second number. Keep in mind this is going to be square root because it's difference of 2 squares. Cool. And first number minus second number. Beautiful. Now, is this neater than that? Maybe not. But it's always convenient to be able to switch things into different forms. And when we get into sketching, you're going to want to be able to flick around these things a lot, just because it gives you more options in how to deal with certain things. Okay, what about this guy? Well, first number plus second number, first number minus, oops, 3, minus second number. Cool. Okie dokie. If we cruise over to here, well, now we've got a problem because it's, we've got a whole lot of fractions in here. Well, that's fine, that's still a number. So, first number, and then, oh, hang on, this has got a plus. Well, difference of 2 squares doesn't work if I'm adding the 2 squares. So, we've got a problem. This thing won't go into difference of 2 squares. Well, that's weird. Maybe that just happens sometimes with fractions. Alright, well, we'll keep going with these. First number, I've got a minus here, so yeah, I can definitely do this. Alright. X minus 5 on 2 plus, well, I've got the square root of a quarter. And I've got x minus, minus 5 on 2 plus square root of a quarter. Now that's all well and good, but we should think about this for a second. Hang on, square root. I can take the square root of the top and the square root of the bottom to simplify. Square root of 1 is 1, square root of 4 is 2. So this is the same as x minus 5 on 2 plus plus 1 on 2, and x minus 5 on 2 plus 1 on 2. Well, hang on, fraction and fraction, I should be able to add those, particularly since they've already got the same denominator. So negative 5 on 2 plus 1 on 2 would be negative 4 on 2, which is just minus 2. Negative 5 on 2 plus 1 on 2 is negative 4, hang on, one of these, oops, that should have been a minus, silly. Let's fix that, sorry about that. So negative 5 on 2 minus 1 on 2 would be negative 6 on 2, which is negative 3. Oh, that's weird. This one ended up nice and neat. All these other ones ended up with really ugly stuff. So why did that happen? Well, if we look back at this, we didn't go down our list. We had nothing to factor in common, but then we could have done this by recognition. Two things that times the 6 and add to negative 5, negative 2, negative 3. So this is why you always want to go down your list, because we could have saved all this working if we actually had gone down our list. But even if you miss it, like you might just fail to recognize some multiple or something, you can still do completing the square and then difference of two squares on that, and you'll still get what you would have had you done recognition. Having said that, know your times tables makes recognition easier. Okay, so we've got this guy, great. Difference of these. Keep in mind, this is out the front, so we could either do difference of two squares on this, or we could use this in the factor. I'm going to, yeah, I'll use this in the factor, why not? So I've got 2 lots of x plus 2 plus root 12, 2 lots of x plus 2 minus root 12. Cool, and as some of you have probably already noticed, hang on, we've got a surd in here, so we can neaten that up. 2 lots of x plus 2 plus 2 root 2 and 2x plus 2 minus 2 root 2. And then if you're doing really well, you might notice, hang on, I've got a whole bunch of 2s, so I can take out a common factor of 2 from this, a common factor of 2 from this, so I end up with a 4 out the front of x plus 2 plus root 2 and x plus 2 minus root 2. Now you may not be able to do that on the fly, that's fine, it might take you a little bit of time, that's fine. I'm just running out of board space. Beautiful, okay. Last thing, we want to do this one. Well, hang on, I've got a plus, so I can't do the difference of two squares. So that's a little bit annoying. Now, what we've figured out is that we can factorise almost anything now, because if this is an even number, great, we can factorise it. If this isn't an even number, we can still do it. There's just fractions will turn up. Even if it works with recognition, we can still use this method. Great. So when will this break? This will break if this front number doesn't take out a common factor. So if we had something like 5x squared plus 6x plus 7, I've got nothing that I can divide all of these nicely by. And so I can't run completing the square. Having said that, you could turn this into 5 lots of x squared plus 6 on 5x plus 7 on 5, and you could go from there. These all turn into really ugly numbers. You'll get 3/5 when you simplify it, but it's still possible to do. So completing the square actually will work for any trinomial, and trinomial is where you've got an x squared, an x, and a constant. It'll work for any of those, and you can make it so that if you have something like 5x squared minus 36, if you have something like that, you could run difference of two squares on that, or you could turn it into this and then run completing the square on it. So completing the square is very powerful, it's one of my favourites, and it's one of my defaults even, but it does take time. So you've got to weigh that up a little bit depending on what the scenario is. So that's completing the square. This definitely does take a bit of practice. You've got your sheet to run through all the textbook. If you have any troubles or anything, do email me. Other than that, best of luck. Cheerio.